Hey y'all! So this video is going backwards compared to the last video that y'all watched. We're now going from a graph that's given to you to writing the equation. So it's completely going backwards. What we're going to do is we're going to take it one piece at a time. We're going to look at where the points are on this graph and figure out a couple things at a time. So as you know, we're working with cos and sine functions. What we're going to do is looking at where this graph hits the y-axis, let's try to figure out what the parent function will be. So if you remember the parent functions, between cos and sine, the one that actually hits the y-axis at its middle point is your sine function. So I'm going to go ahead and call this the sine function. And let's see what we can figure out. So I know sine usually starts here. It goes high, then goes low, and then here's the completion of one pattern. Okay, so from midpoint to midpoint, that's how a sine function works. So now what I need to figure out, the next thing it's asking me for is the period. And as you know from the last video, one period is the time it takes, or the amount of radians it takes to complete one pattern. And just like we noted right now, midpoint to midpoint here before it starts back again, it takes, if you take a look at that, it takes 4 marks to complete that. And if you remember, every single mark is actually pi over 6, 30 degrees, because pi over 2 is 90, and so every mark will be 30 degrees, pi over 6. So if we're looking for the period, what we need to write down is that we have 4 marks, 4 pi's over 6. Which really simplifies to 2 pi over 3. So without much work, we already know the period. So let me write that down. 2 pi over 3. And now we need to find the b value. So if you remember, there was a small little way that you could always find that, and it's always 2 pi over your b value. Now, since we're looking for b, all we have to do is compare these two. And notice that the 2 pi at the top is the same, so really what that means is that b is simply 3. Okay, the next thing we're looking for is amplitude. Remember, amplitude is the distance from your midpoint to your highest point. Now, another word for midpoint, because midpoint is simply refers to one of the points. Now, the actual line that goes through the midpoints, all of them, this right here, we actually call the center line. So what I want you to notice is that the center line here is at 4, which means that we've actually gone up. There's been a vertical slide of 4. Normally that center line is sitting on the x-axis for the parent function, and so having gone up 4 tells us that the center line, that our vertical slide is up 4. So we know in our equation we're going to have to write down a plus 4 at the end. But now amplitude is the distance between that center line to the highest point. So if you take a look at that, because each mark on the y-axis now represents 1, this actually is a distance of 2. So your amplitude for this is 2. Okay. Min and max, so we've talked about this before. We never called it this for these functions, but our maximum is just what you're thinking. What is the highest point? And the highest point is 6. The minimum, the lowest point, is 2. Phase shift, have we gone left or right? Well, that's kind of tricky because we're calling it a sine function. We're going to say that there has not been a shift because of the midpoint being on the y-axis, just like it is for the parent. So if we're calling this a sine function, then no, there has not been a shift. However, if we call this a cosine function, remember cosine and sine functions are practically the same. The only difference is that they're a shift off from each other, even the parent function. So if we call this a cosine function, then yes, there has been a shift because cosine, the highest point starts on the y-axis. And so if we call this a cosine function, then we would have to say, I'm going to say if cos function, then we will have to say that the phase shift is based on the highest point, because again, the highest point is normally on the y-axis, and it's simply 1 mark off. And like we said earlier, 1 mark, each mark is pi over 6. So really, if we call this a cosine function, then we have to say that the phase shift is to the right pi over 6. Okay, so now let's actually try to write the equation. So let me write this as, since we're talking about cosine, let's actually go ahead and write it as a cosine function. So y equals cos of theta. Now I'm leaving blanks in here so we can go back and fill in stuff. So I know amplitude is 2, so let me go ahead and put that at the front. I know my phase shift for a cosine function is pi over 6 to the right, so I'm going to put this in parentheses, minus pi over 6. And lastly, I know the b value, based on the period that we found, is 3. And that's going to go right after the cos, right in front of theta, just like that. And there you go, there's your cosine function. Now, if we call this a sine function like we originally recognized, we know there is not a phase shift, but everything else still applies. The amplitude is still 2, the b value is still 3, and the vertical slide is still 4. So y equals to sine 3 theta plus 4. And if you want to, you could put theta in parentheses if it makes you feel better. And there you go. Number 2, notice that the high point, so I'm looking, every time I look at a new graph, I always look at the y-axis to see what part of the graph actually hits the y-axis. And on this graph, it's the highest point. Now, if I think back to my cosine and sine parent graphs, between those two, I know my cosine function works that way, where the highest point is directly on the y-axis. So because it's true here as well, the highest point is on the y-axis, I'm going to call this parent function the cosine function. Okay, the period, again, it's based on how many radians does it take to complete one pattern. Because I know it's a cosine function, I'm just going to go from the highest point to the highest point, the next highest point, because I know after that it's just going to come back down. So to go from one high point to the next high point, it takes one entire revolution, 2 pi. So I'm going to say that the period is 2 pi, and actually there's no work to be done there because we know 2 pi is normally the period for a parent function as well. So what we're going to say is that the period is 2 pi, and so the b value is simply 1. If you wanted to, again, you could always set that equal to 2 pi over b, which will also get you that same answer, that b equals 1. Okay, the amplitude, so again, remember it's the distance from your center line to the highest point. So now we need to go and find the center line. So let me go down right here where it says max and min. Let's figure that out. Max is at 1, 2, 3, 4, 5, y equals 5. And the minimum is at -3. So what I need to do now is notice that the complete distance from max to min, the complete distance is 8. Now my center line would be half of that. So 4 marks down from the highest point would actually be right over here, because that will be your center line. It'll cut your graph directly in half. So now I know that my center line, because it's above, it's away from the x-axis, I know my d value now. The d value is a vertical slide, which is a positive 1, because we've gone up 1 from the x-axis. So now I know that my amplitude is the complete distance from max to min, cut in half, which is 4. Let's see, phase shift. If I call this a cosine function, there is no phase shift because your highest point is sitting on the y-axis. But if I call this a sine function, if I call this a sine function, remember sine looks like this, and so on. So if I call this a sine function, I have to look at midpoints, midpoint to midpoint. So this one I'm not going to look at because that's actually a change of shape altogether. So I'm going to look back at this one because I know from here the sine function normally goes from your midpoint up and then down and then back to the midpoint, just like that. So if I want to call this a sine function, I'm going to look at it from here, from this midpoint, to this midpoint right here. So let's figure out what kind of shift has happened, what kind of phase shift has happened if we call this a sine function. So normally this point is at 0, 0. Now if we're talking strictly phase shift, how far to the left have we gone? So it's 3 marks over, and as you know, 3 marks is pi over 2, so we would say for sine, for the sine function, the phase shift is left pi over 2, because there are 3 marks. So since we're talking about it being a sine function, that we can call it a sine function, I'm going to go ahead and write down the sine equation. So sine of theta, and I know my amplitude is 4. I know the b value is simply 1, so I don't really need to put it there. And because we're calling it a sine function, like we said, we have a phase shift of left pi over 6, so I'm going to write down plus pi over 2 left. I'm going to write down theta plus pi over 2. And we have a vertical slide up 1. So there you go. Now if I call this a cosine function like I originally noticed, I'm going to say that this is y equals cos of theta. And again, the amplitude is still valid. The b value is still 1. Now because cosine did not have a phase shift because of the shape, there's no c value, so it's just theta by itself. But the plus 1 is still valid, and there you go. Okay, now the next example, on page 15, this is a super tiny graph, but again, I'm going to look at the y-axis to see what kind of function I can call this. So I notice that the highest point is on the y-axis. Again, between sine and cosine, the function that has its highest point sitting on the y-axis is cosine. So I'm going to go ahead and call this the cosine function. And to figure out the period, I'm going to go from high point to high point because that will complete one pattern. And let's see, it takes 3 marks, so 1, 2, 3 marks. And technically, you would say that each mark is pi over 6, so that would be 3 pi over 6, which does simplify to pi over 2. And if you know that 3 marks is pi over 2, then you can go ahead and put it down. So I know my period is pi over 2. Now to find the b value, you might actually have to work on this a little bit, or you may be able to figure it out. But if I know that the b value, or to find the b value, it's 2 pi over b, 2 pi being the normal period, but my period now is pi over 2. If I set those equal to each other, I can cross simplify to figure out what my b value is. So I'm going to cross multiply just like that, and so that will get me pi times b equals 2 times 2 is 4 pi. So now if I divide pi over, all of the pi's cancel, and so that leaves me with b equaling 4. So now I know that the b value is 4. Okay. So really what that means, if you think about it, is that your graph has gone through a horizontal shrink of 1 over 4, because remember, it's the opposite of the b value itself. Okay, amplitude. Again, let's go in and figure out where the center line is. It's right over here, cutting the graph in half. So I know my center line is sitting right at, and on this one, it's asking you to use every mark on the y-axis as 4. So this is -4, -8, -12. So my center line is at -12. So what that tells me is that my d value is -12 because it's gone down from the x-axis 12 marks, 12 units. So I'm going to go ahead and say that my vertical slide is -12. It's gone down 12 units. And then, so if every mark is 4 units, then I know my total distance from max to min, max which is at -8, min which is at -16, I know my total distance is 8, cut that in half, and that gives me an amplitude of 4 units. Okay, my phase shift. Now because I'm calling this a cosine function, I can just compare high point to high point, and because the high point is sitting right on the y-axis, I'm going to say there is none for the cosine. Now again, if I look at this as a sine function, then we know that we do have a phase shift. Sine again starts at a midpoint and then goes up and then comes down and then meets back at the midpoint. So if I look at it that way, I will have to look at this point over here. And because this point is a little bit off, which is a bit annoying, but because it's a little bit off, let's actually just resort to calling this a cosine function. It's not drawn to scale, and so let's not get into that issue of where exactly it's at. But we could, if we had this a little bit more on an intersection more directly, then we could call this a sine function. But we're going to ignore that for now. So let's actually just stick with the cosine equation. So amplitude we found out is 4, so there's your A value. B is also 4, so I'm going to put that in front of theta. Phase shift is none because I'm calling it a cosine function, high point to high point. So there's that. And I am going down 12 units. And there you go. I'm going to stop there, guys. We're going to do some more of these in class, but try the next few examples if you would like to, and we're going to do the rest in class.